Integers. Operations are inverses when one of them undoes what the other does. What would undo adding 5? The answer is subtracting 5. Addition and subtraction are inverses. Adding a number and then subtracting that same number leaves you where you started on the number line. This is the inverse property of addition. Starting at 4, if we add 5, we end up at 9. But then if we subtract 5, we end right back at 4. This is true for any two numbers. Start with A, add B, and then subtract B. You end up with the number you began with, A. We started with the addition question. What number results when we add 5 and 4? The answer is 9. That leads to two new related subtraction questions. Starting with 9, what number do we get when we subtract 5? And also, starting with 9, what number do we get when we subtract 4? Subtraction was invented to undo addition, but it now can be used to ask new questions. Here's what 9 minus 5 looks like on the number line. Start at 0, move to the right 9 spots, and then to the left 5, and we end up at 4. Here's 9 minus 4. Start at 0, move 9 spaces to the right, then 4 spaces to the left, and we end up at 5. Subtraction was invented to undo addition, but this new operation allows us to ask new questions. And the number system, up to that point, couldn't provide answers. For example, what is the result of subtracting 7 from 4? There was no answer to questions like this in the whole number system, which was all there was until about 500 years ago. The whole numbers are not closed under subtraction. When two whole numbers are subtracted, the result may not be a whole number. This led to the invention of negative numbers. They were called negative from the Latin negare, which means to deny, since people denied that such numbers could exist. They weren't used much until the Renaissance and were only fully accepted in the 1800s. If you have trouble with negative numbers, so did most everyone else. The reason for their acceptance over time was that mathematicians realized there was a need for each natural number to have an opposite counterpart. Once this occurred, the term integers was adopted to represent all positive and negative whole numbers. Below is an example of the number line that integers create. All right, the negative integers are numbers to the left of 0 on the number line. They are all less than 0. And the further you go to the left, the smaller the number becomes. 0 is neither positive or negative, and numbers to the right of 0 are greater than 0, and the further you move to the right, the bigger the number gets. When working with only positive numbers, it's easy to understand value. In other words, we know that 10 is bigger in value than 5. However, negative numbers work differently. The larger the magnitude of a negative number, the less its value, because the further left it is on the number line. So that means that negative 10 is actually less in value than negative 5. With the addition of negative numbers, the number line no longer has a beginning or an end. In the case above, ... at the left and right means that the sequence continues in both directions forever. Due to this, there is no largest integer, nor is there a smallest integer. The integers are closed under both addition and subtraction. No matter how many integers are added or subtracted from another integer, the result is an integer. The picture below shows 3 different people at 3 different elevations. So this person is scuba diving below sea level. This boat is sailing at sea level, and this person is hiking above sea level. Let's write an integer to represent each situation. Sea level is 0. So the sailor is at 0 altitude, sea level. That means the hiker is above sea level, This is like to the right on the number line in the positive direction, where it's 780. And that means below sea level is to the left in the negative direction, negative 30. And here are the answers.